Hello, this is Yashvin. In this video, I'll be solving paper 4 variant 2, May June 2020, 0620 chemistry. Starting with question number 1a, give the name of the process that 1 occurs when a gas turns into a liquid. So this process is condensation. 2 occurs when a solid turns into a gas without first forming a liquid, and this is sublimation. 3 is used to separate a mixture of liquids with different boiling points. This is fractional distillation, in which different fractions are obtained on the basis of their boiling points. 4 is used to extract aluminium from aluminium oxide, which is electrolysis. 5 is used to separate a mixture of amino acids, and this here chromatography is used. B. The symbol of elements in period 2 of the periodic table are shown. For each of the following, give the symbol of an element from period 2 which matches the description. Each element may be used once, more than once, or not at all. Which element 1 combines with hydrogen to form ammonia? So ammonia is NH3. So here we can take nitrogen. 2 makes up approximately 21% of clean dry air, and this is oxygen. Has atoms with only 2 electrons in the outer shell, and that means an element from group 2, which is an atom which has 7 protons, which mean an atom with the atomic number 7, which is nitrogen. 5 is a monoatomic gas. Monoatomic gas means it exists in the form of a single atom, which means this is neon, since it is unreactive and does not react with any substance. 6 is a soft metal stored in oil. So here we have lithium from group 1, which is a soft metal. 2. Fluorine forms both ionic and covalent bonds. So it forms ionic bonds when it bonds with metals, and covalent bonds while bonding with non-metals. 8. Magnesium reacts with fluorine to form ionic compound, magnesium fluoride. The electronic structure of an atom of magnesium and an atom of fluorine are shown. 1. Complete the dot and cross diagrams to show the electronic structure of one magnesium ion and one fluoride ion. Show the charges on the ions. Alright, as you can see over here, magnesium has 2 electrons in its outermost shell, and because of being a metal, it loses these electrons, and that leaves with only 2 shells which are complete. And since magnesium loses 2 electrons, the number of protons is greater than number of electrons by 2, and so it gains a charge of 2 plus. Similarly, fluorine has the second shell, which is not complete. It needs 1 electron to complete its outer shell, and this 1 electron comes from magnesium atom. Since now fluorine has 1 extra electron, 1 more electron than protons, it gains a charge of -1. Or here you could also simply just write this negative sign without the 1. 2. What is the formula of magnesium fluoride? Right. Once again, to the formula of a compound, we write the names of the symbols of the elements followed by their valency. So magnesium has a valency of 2. No, not the valency. Followed by writing their charges. Similarly, fluorine forms a charge of -1, and now you cross it. And this leaves with magnesium crossed with the number 1 and fluoride ion or fluorine atom with the number 2, which means magnesium has 1 atom for every 2 fluorine atoms. 3. Magnesium fluoride does not conduct electricity when it is solid. What can be done to solid magnesium fluoride to make it conduct electricity? In your answer, explain why magnesium fluoride conducts electricity when this change is made. So for any substance to conduct electricity, there have to be charges to carry the current, and that is why magnesium fluoride in solid form, which has all of the charges bound in a lattice structure, cannot conduct electricity because charges are not able to move. So you can either melt it or make it into an aqueous solution. So heat it until it's molten. That's it. B. Carbonyl fluoride is a covalent compound. The structure of the molecule of a carbonyl fluoride is shown. Complete the dot and cross diagram to show the electron arrangement in a molecule of carbonyl fluoride. Show outer shell electrons only. Right. So carbon has 4 electrons in its outer shell, and that means it needs 4 more electrons. As you can see over here, two bonds between carbon and oxygen means they share 4 electrons in total, 2 from carbon and 2 from oxygen. And now carbon shares 2 electrons with one fluorine atom over here and one fluorine atom over here. So 1, 2, 3, and 4 means carbon now has 8 electrons in its outer shell, which means a complete outer shell. Right. Since here we are only supposed to be drawing dot and cross diagram, I can have a cross for the fluorine atoms. So it has 6 atoms outside of the bond. One of them forms a bond with carbon. Similarly over here, this is a dot over here and then a cross. So 7 fluorine atoms and 1 carbon atom. So we have 2 carbon atoms over here, and here we'd have 2 carbon atoms because we have a double bond. Similarly, 2 oxygen atoms. And that's it, a complete outer shell, because oxygen previously had 6 electrons in its outer shell. After sharing them, it becomes a complete shell of 8 electrons. See, the melting points of magnesium fluoride and carbonyl fluoride are shown. 1. Explain using your knowledge of structure and bonding why magnesium fluoride has a higher melting point. Right? So carbonyl fluoride is a covalent compound, and the intermolecular forces in covalent compounds are weaker than the ionic bonds in an ionic compound. And that is going to be the answer over here. Strong ionic bonds scores you 1 mark, and the other mark is for the point that it needs a lot of energy. These bonds need a lot of energy to be broken down. Explain using your knowledge of structure and bonding why carbonyl fluoride has a low melting point, right? So carbonyl compound again is a covalent compound, and that means the forces of attraction between molecules are weak, or intermolecular forces. Three A. Sulfuric acid is made from sulfur in a 4-stage process. Stage 1, sulfur is converted into sulfur dioxide. Stage 2, sulfur dioxide is converted to sulfur trioxide. Stage 3, sulfur trioxide is converted into oleum. And in stage 4, oleum is converted into sulfuric acid. How is sulfur converted into sulfur dioxide in stage 1? So this is addition of oxygen, and that is done by heating sulfur in air. To describe how sulfur dioxide is converted to sulfur trioxide in stage 2. So this is an important process, the conversion of sulfur dioxide to sulfur trioxide. Your answer should include equation for the reaction, temperature used, and the catalyst used. Alright, so here we have sulfur dioxide with addition of oxygen is converted to sulfur trioxide, and then I'll balance this equation. Sorry, this is a 2 over here. the temperature used. Alright. So 1 mark for the equation, 1 mark for the temperature, which is 450 degrees Celsius. The catalyst as vanadium oxide. Three, the reaction in stage 2 can reach an equilibrium. What is meant by the term equilibrium? So this is rate of forward reaction is equal to rate of backward reaction. This is 1 mark, and the second mark is scored by mentioning the fact that concentration of products and reactants remains the same. B. Sulfur trioxide is converted into oleum in stage 3. What is sulfur trioxide reacted with to convert it into oleum? So it's reacted with concentrated sulfuric acid. C. Oleum is converted into sulfuric acid in stage 4. Write a chemical equation for the conversion of oleum into sulfuric acid. Alright. So we have oleum by the addition of water is converted to sulfuric acid. And we have 2 of these. D. When copper is reacted with hot concentrated sulfuric acid, sulfur dioxide is formed. Balance the chemical equation for this reaction. So there is no change in copper. And as you can see over here, we have 2 sulfur atoms on the reactant side, product side, and that means there must be 2 atoms of sulfur on the reactant side as well. So here we have 4 hydrogen atoms, and balancing it over here we have another 2. E. Sulfur dioxide is a reducing agent. Give the color change that occurs when excess sulfur dioxide is bubbled into acidified aqueous potassium manganate. Starting color of the solution. The solution or color of the solution of potassium manganate is purple, and the final color after the addition of sulfur dioxide is colorless. F. When sulfuric acid reacts with ammonia, the salt produced is ammonium sulfate. Write the chemical equation for this reaction. Right, so since no other products form, we have ammonia in the formula NH3, and then we have sulfuric acid, H2SO4. Now the product over here, ammonium sulfate, has the ions ammonium and sulfate. Once again, to write the formula, we write the names of the ions or the elements which are present in the compound. So ammonium ion and followed by sulfate ion. Sulfate ion has a charge of -2 and ammonium ion has a charge of +1. And then we cross these. So here we have the product as ammonium sulfate. You put brackets around the ammonium ion to indicate the fact that there are 2 of this whole ion and not just hydrogen or nitrogen. And that's it, along with balancing the equation as well. G. Barium sulfate is an insoluble salt. Barium sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. 1. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of barium sulfate. So you need to have some a salt of barium to so that it would react with ammonium sulfate, and here I'm going to be writing barium chloride to write an ionic equation for this precipitation reaction includes state symbols. Alright, so we need to write the ions of the reactants and then the product. Since barium sulfate is the product which forms, we need to start with the ions of barium and sulfate. Barium has a charge of 2 plus barium ion. And since this is an ion, we need to write the state, which is aqueous. Similarly, sulfate ion has a charge of -2, which is also in aqueous form, and we only need one of both of these ions to cancel out the total charges, which are 2 plus and 2 minus. 2 plus and 2 minus gives 0, which means we simply have one barium atom and one sulfate ion. 4. Oxygen is produced by the decomposition of hydrogen peroxide. Manganese oxide is the catalyst for this reaction. A. What is meant by the term catalyst? So we write the definition of catalyst over here, which is B. A student measures the volume of oxygen produced at regular intervals using the apparatus shown. Large lumps of manganese oxide are used. Alright, so here we have the reaction graph. What happens to the rate of this reaction as time increases? In your answer, explain why the rate changes in this way. Alright, so as you can see over here, this gradient, the slope of the graph eventually levels off, which means the rate of reaction is gradually decreasing and up to the point over here, and then the reaction completely is stopping after it levels off, after the graph levels off. Rate of reaction decreases because the slope of the gradient of the slope over here is decreasing, and that is exactly basically how we calculate rate of reaction. And in the answer, explain why the rate changes this way. So rate of reaction is here we need to consider the facts that affect the rate of reaction, and in this reaction, we take into account the concentration of hydrogen peroxide, since this is the only reactant. So as a rate of reaction decreases, because gradually concentration of hydrogen peroxide decreases. And from the collision theory, we know that the greater the concentration, the more likely and more frequent the rate of collision is. And since concentration over here is decreasing, collision frequency also decreases, which results in decrease in rate of reaction. Collision frequency decreases because of decrease in concentration of the reactant, and at the end, since there is basically zero concentration of hydrogen peroxide after it is used up. So there are no molecules of hydrogen peroxide present, and that means zero concentration. And due to that, the rate of reaction over here is zero. That is, no reaction occurs at the end when the graph levels off. See, the experiment is repeated using the same mass of manganese oxide. Powdered manganese oxide is used instead of large lumps. All other conditions stay the same. Sketch a graph on the axis in B to show how the volume of oxygen changes with time. Alright, since the mass over here remains the same, but the only change is change in surface area. Powdered manganese oxide has a much larger surface area than its large lumps, and that means the collision frequency and the rate of reaction increases. Due to this, the gradient of the graph would be of a greater value, which basically just means a steeper curve. But it levels off at the same amount of volume because we have the same amount of hydrogen peroxide. The same amount of hydrogen peroxide, and the only difference is that the graph would be steeper value, that is, the gradient would be a greater value, but the final volume of oxygen produced would be the same. V, in terms of particles, explain what happens to the rate of this reaction when temperatures increased. Rate of reaction increases because increase in temperature means molecules gain kinetic energy. And this in turn means they move faster. And as a result of this, collision frequency increases. They are more likely to collide at a higher speed than compared to a slower speed. And since greater number of collision occurs, more molecules have sufficient energy to react. Which is the activation energy. And without this activation energy, molecules cannot react. E, the equation for the decomposition of hydrogen peroxide is shown. 25 cm cube of aqueous hydrogen peroxide forms 48 cm cube of oxygen at room temperature and pressure. Calculate the concentration of aqueous hydrogen peroxide at the start of the experiment using following steps. Right. So now we'll start with calculating the number of moles of oxygen formed. Okay. So moles for gas are equal to volume divided by the molar volume, which is 24 dm cube of every gas. But to calculate the moles, first we need to convert volume from centimeter to dm cube. And here the volume of oxygen is 48 centimeter cube. I'll divide this with 1000, which gives the answer as 0.048 dm cube. And now I'll divide this with 24, and this gives the answer as 0.002 moles. Then followed by deducing the number of moles of hydrogen peroxide that decomposed. Alright, deduction requires the use of ratio set in the equation. As you can see over here, 2 moles of hydrogen peroxide give 1 mole of oxygen. So here we can use cross multiplication. 2 moles of hydrogen peroxide give 1 mole of oxygen. So how many moles of hydrogen peroxide do you get by 0.002 moles? You multiply these two values and these two values. Divide the product of 2 into 0.002. The product over here is going to be 0.004 with x, which is basically 1. So, and that just means 0.004 moles of hydrogen peroxide that decomposed. And this can also be deduced by, you can just look at the set of the ratio over here. 2 moles give half of the value of 2, which is 1, and that means if you have half the value already, what is the double of this? You can simply multiply 2 over here and you'd get the answer 0.004. Calculate the concentration of hydrogen peroxide in mole per dm cube. Right. So we have the moles of hydrogen peroxide and also the volume given in the question, and that means concentration is equal to moles over volume. But you first need to convert the volume in the question, which was 25, into dm cube by dividing it with 1000, which is 0.025 dm cube. And so we have 0.004 moles divided by 0.025. This gives the concentration as 0.16 mole per dm cube. Oxygen can also be produced by the decomposition of potassium chlorate. The only products of this decomposition are potassium chloride and oxygen. Write a chemical equation for this composition. So we're already given with the formula of potassium chlorate. The resulting products are potassium chloride, forming the compound, the formula of the compound potassium, and chlorine, the symbols of the elements over here. They both have charges 1 plus and minus, and that means in a single molecule of potassium chloride we only have one of each of these atoms, followed by oxygen. Now we'll balance this. Since the number of oxygen is not balanced over here, we could increase it to 6 and then here multiply by 2, and that means 2 potassium and chlorine atoms as well. 5. Electrolysis of concentrated aqueous sodium chloride using inert electrodes forms chlorine, hydrogen, and sodium hydroxide. A. What is meant by the term electrolysis? So you start by writing the definition of electrolysis, which is B. Name a substance that can be used as the inert electrodes, which is an unreactive substance. This can be graphite over here. C. Write an ionic half equation for the formation of hydrogen during this electrolysis. Half equation for the formation of hydrogen. So we always start half equations by the ions. Hydrogen ion has a charge of plus, and alright, so this means to convert this ion into a neutral atom, you need to add electrons. Since this is a charge of plus, that means there is an extra proton or a shortage of electron. So that is why you add an electron over here to cancel this one charge. So the number of electrons added over here depends on the charge over here. Since this is only 1 plus, you need to convert this state into 0, and 1 plus, what is it that you need to add to 1 plus to convert it to 0? So here we only have 1 electron, which gives hydrogen, but hydrogen always exists as a diatomic molecule, and that means to form this diatomic molecules we need to have 2 hydrogen ions in the first place, and so we need to remove 2 electrons, 1 from each hydrogen ion. D. Give the formula of the 4 ions present in concentrated aqueous sodium chloride. So you first start with the compound, which is sodium chloride, pretty basic. You have the sodium ion, chloride ion, and then you have the solution, which is water, right? These broken down into ions give us the charges hydrogen ion, And then we have the last ion, which is hydroxide ion. E. Explain how sodium hydroxide is formed during this electrolysis. Alright, so in this reaction, hydrogen and chlorine form at the electrodes, which means the elements left behind in the solution are sodium ions and hydroxide ions, and then these combine to form sodium hydroxide. Six A. Propane reacts with chlorine in a photochemical reaction as shown. 1. What type of reaction is this? Alright, since we have the halogen, this is a substitution reaction. 2. What condition is needed for this photochemical reaction to occur? This requires ultraviolet light. 3. Draw two structural isomers of compounds with the formula C3H7Cl. Show all of the atoms and all of the bonds. Starting with the backbone chain, which is 3 carbon atoms, and then we have the remaining bonds. One of the isomers could be chlorine in the first carbon, and the second isomer would have chlorine in the second place. Some students might make mistakes by drawing a structure. For example, if you drew this one, some students, instead of drawing this chlorine in the middle, would draw it over here where I have hydrogen right now, but that would be wrong, because either way, if you placed chlorine over here or here, it would still be the first carbon, and so you need to have it in the first place and then the second place. B. Propene reacts with chlorine in addition reaction as shown. 1. State why this is an addition reaction. Alright, because two molecules join to make one product. Or two reactants is a better term to be used over here. Two, the structures of the reactants and the products of this reaction are shown. Some bond energies are shown in the table. Calculate the energy change for the reaction between propene and chlorine using the following steps. So first we start with calculating the energy needed to break the bonds. As you can see over here, this double bond is broken so that these chlorine atoms can react with this compound, and that means here not only one double bond is broken, but also this single bond between two chlorine atoms is broken, and that means we have the bond energy 612 along with 242, which is, so these add up to be 612 plus 242 is equal to 854. Let me write this sum over here. You need to show the workings over here in the space given. Calculate the energy released when bonds are formed. So here you need to see which new bonds are formed. The new bonds formed over here are these two carbon and chlorine atom bonds, along with this third bond between carbon and carbon, because As you can see over here, both of these bonds were broken. The double bond was broken, and that resulted in no bond between these two carbon atoms. So now we also need to form this single carbon atom along with the two chlorine and carbon atoms. So here we have 2 times the bond energy of carbon and chlorine, which is 339, plus the carbon-carbon bond, which has the energy 347, and this has sum of 1025. Calculate the energy change for this reaction. This is going to be 854 minus 1025, which results in negative 171 kilojoules per mole. I forgot to write the energy over here. C. There are 3 functional groups in compound A. Alright, so this is compound A over here. One, name the homologous series of compounds that contains the following structures. Alright, so double bonds are found in alkenes, which are the unsaturated hydrocarbons. But here you need to write the specific series, homologous series. And OH group is found in alcohols. Similarly, this is the carboxylic acid group. Two, what would you observe when compound A is added to aqueous bromine? You have a double bond which would open up and react with the halogen. So this bromine, which is originally brown in color, would turn colorless because it would be added to this compound. So the color change would be from brown aqueous sodium carbonate. This would result in neutralization reaction, and since this solution is a carbonate solution, that means carbon dioxide would form, and due to this production of carbon dioxide you would expect bubbles, the formation of bubbles. D. Compound A can be used as a single monomer to produce 2 polymers. Alright, draw one repeat unit of the addition polymer formed from compound A. So the only change over here is you open up these bonds and then put brackets around them. So you have 2 carbon atoms, their functional groups, and then you have these brackets. 2. What type of condensation polymer is formed when formed from compound A? This is a polyester polymer forms because it results in ester bonds. And that's it. We're done with this paper. Thank you for watching.